Hello and welcome to our lesson on periodic functions. So what we're doing with this lesson is we're trying to prepare for graphing sine, cosine, tangent, for graphing trig functions. And that's a whole different animal when we're used to graphing polynomial functions and rational functions. So it's just a different thing. What we're going to notice in these periodic functions is certain types of behavior, not unlike what we've seen before. So I want to go through in this lesson just some terminology to kind of get you familiar with some of the words and things that we're going to see happen in these sine, cosine, tangent, these trig functions, and then we'll build from there. Okay, so it's just some terminology today. Should be a pretty simple lesson. So first of all, what does it mean for a function to be periodic? What happens with a periodic function is that it repeats a pattern of y values at regular intervals of x values. So you're going to see this pattern of y's repeat as we move along the x-axis. And the graph that results from that behavior from a periodic function is very cyclic. So you're going to see these cycles that repeat, and it's uniform. So there's uniformity. It's cyclic, and there's uniformity along both of our axes. So we have this cycle, this pattern of y values that repeats as we go at some constant speed along the x-axis. Okay, so these graphs, they also contain what we call a midline. Now this would be just something that we sort of insert into the graph. It's not actually shown on the graph, but it's something that we will reference. And what a midline does, it's a horizontal line. You can basically cut the total height of your graph in half. And again, it's just something that we use as a reference when we get to our trig functions, graphs of trig functions. Okay, so let me just show you an example. The one we have here is going to be very similar to what we will see when we graph the sine function, the sine curve we call it. So at 0, 0 we have a point, and then at 1 and 2.5 we're here, and then at 2 we go up to 5, and then at 3 we're back down to 2.5, and then at 4 we hit 0 again, and then we have 5, I lost track of where it was, 5 and negative 2.5, and 6 and negative 5, and 7 and negative 2.5, and then 8 and then 0, and then I should have put probably a few more values in the table, but this is what one complete picture is going to look like. And what's going to happen with our trig functions is once we get through what we call this cycle, and we'll talk more about that in a few minutes, is that it just starts to repeat again. So from here, it's like the starting point here, we would go back up to 2.5, and then back up to 5, and then back down to 2.5, and then back down to 0, and the whole thing would just repeat. And on this side, it would happen the other direction. So I'm just going to try to sketch this out here. Oops, let me try to connect these nicely. Easier said than done. And I missed. Okay, so when you connect your points on your graph, you want to actually try to go through them, which I'm trying my best. This is pretty tough. And okay, so we're going to see this type of behavior, okay, where there's this cycle that just repeats, okay? This is an example of what a trig function might look like. This is an example of what a periodic function looks like. Now, the total height of this graph, if I look at the x-axis, would be actually my midline. So I'm going to put a little dotted line in here. I'm going to call that my midline, and that's the middle because there's exactly 5 units in length of or height of that graph above, and there are exactly 5 units in length of that or height of that graph below. So the total height, we're going from -5 to +5 is 10. If I cut that in half, then my midline should have 5 units above, 5 units below. So my midline is going to be at 0 here. Again, this is the midline of the graph, and again, that's just cutting that horizontal height of the graph in half. Okay, so it's something of what a periodic function looks like. Now, just to help you grasp that a little bit better, I have some more pictures here for you so we can try to establish what is periodic versus what is not. Now, what's happening in this first picture is exactly what I was trying to show you in the first picture. So if you'll notice, we're going up, we're coming back down, and then we're going up again. Now, this is the same point I started at here. And what happens after I hit that point is that same picture repeats. And then I hit that point again, and then there's that same picture repeating. So it's the same picture repeating. Now that happens here too. So if you notice in this, I have this picture here, and then it looks like it repeats here, and then it looks like it repeats here. However, this function is periodic, and this second one is not periodic. Because not only do we need for that picture to repeat, but when it repeats, it's the x's and y values that are also repeating. So for example, here we have a point at -2 pi and 0, and don't get too freaked out by the radian measures on the axis there. And then when we start back over, we have at 0, 0 again. So we've moved along the x-axis 2 pi units, but the y value is the same there, right? Or if you look at this point, maybe not, that's between -pi and -2 pi, so between -1 and -2 is -1.5, so -3/2 pi here, and we're up at +1. And then again over here, we've moved to 1/4 pi. That's between, sorry, that's not 1/4. Between 0 and 1, that's going to be 1/2 pi, but we're back up to +1. So we've gone that same distance along the x-axis, and the y value isn't changing, it's repeating. So if we follow the y values, let me get rid of all this and not mess up my graph, my colors. We want the x values to be moving at a constant rate, and we want the y values to be repeating. So y value of, go back here, y value of 0, y value of 1, 0, -1. And then it's 0, 1, 0, -1, 0, 1, 0, -1, 0, and it's just going to keep going. So as we move along the x-axis, we need for those y values to repeat. Now if we go to this next graph, we do see that same picture happening, but the y value here is 1, and then the y value is 2, and then it's 2, and then it's 3, and then 3, and then 4, and then it's 4, and then 5, and then 5, and the y values are growing here instead of repeating like they were in the last one. So as we move along the x-axis, we want to see that pattern of y values. Okay, so hopefully you can see the difference in what's happening there. And you can tell on this one, we don't even have the same picture repeating. The y values are definitely changing, so this one is not periodic. Not periodic. Now, there might be some patterns in these, but we need for the pattern to be repeating y's as x moves along. So that's what we see happening in this picture. Oops, I want my highlighter. Okay, so we're starting at 0, then we get up to 1, and then we're back down to 0 on the y's, okay? And then we go up to 1 again, and then we're back down to 0 again. Then we go up to 1 again, and then we're back eventually down to 0 again. So we see one picture there, looks like it happens again, and then it looks like it's going to happen a third time, and it would just keep continuing, where again we have a y value of 0, and then 1, and then 0, and then 1, and then 0, and then 1. This is periodic. Okay, look at the next one. Y values go from, let's say, this is 2, 4, so 6, and then we're down to 4, and then 2, and then 4, and then 2, and then 0, and then 2, and then 0. Right, the y values are not repeating as we move along the x-axis, so this is not periodic. And here we do have a periodic function, so looks like, again, we're going up to 1, hit 0 again, and then we're going to hit this minimum, bounce back up, and then right there looks like where we started, and then we see that same pattern repeat, and the y values aren't changing when the pattern repeats. So if I could literally slide that one that's in pink to the left or to the right, the green one to the right, and make those map onto each other because the y values are the same, that's a periodic function. Okay, so hopefully you're seeing the idea there. Now, let's put a little more terminology in. when we have a periodic function, we should be able to identify one cycle, and that's sort of what I was doing with the highlighting on the other page. So one complete pattern in our periodic function is what we call a cycle. And if we want to identify a complete cycle, again, it's what I was doing with the highlighting on the front. You really can start anywhere, but I find it easiest to either start at the origin or to start at a max or a min, some very recognizable point, and then just highlight until the pattern repeats. And then the number of cycles that occurs within some specified interval, like when we get to doing this with trig functions, we might look for how many cycles there are from 0 to 2 pi, or from 0 to 360 degrees. That's going to be something that we call the frequency. Okay, so that word will come back. So frequency is how many cycles are there in some specified interval. So let's look at the first one. I can see here, I'm going to start at the origin, and if I highlight until I get back to my starting point, that is what one complete cycle of this periodic function will look like. And here I can see that same picture happening again. So I've highlighted 2 cycles in this particular periodic function. So we could say from 0 to 6, there's a frequency of 2 if we were looking at an interval from 0 to 6. Okay, let me look at the next one here. So I'm going to start back here with this one, and it looks like right there, back to where I started, and then I can go again right there, and then I'm back to where I started, and then I could begin another cycle if I wanted to, but I can't get very far with that one. So I could say 2 complete cycles, and then this one is, I don't know how much of that cycle, but not much of it. So let's just say we can see 2 complete cycles in here. Okay, and then on this next one, you can start wherever you want. I'm going to start at the origin. So here is 1 cycle. And then here would be another cycle, right? Back to where I started. And then let me just highlight this guy here. So what I've highlighted from 0 to, I don't know, 16-ish, looks like I've highlighted 2.5 cycles. Now I just chose to leave this last one off over here, but there is, if I wanted to highlight this is almost 3.5 cycles. So if we wanted to also say this looks like 3.5 cycles, then that would be fine as well. Okay, just so you get the idea of how you can identify a cycle. Now, the period is also related to cycles. So the period of a periodic function. The period of a periodic function is the horizontal length of one cycle. So not how many cycles are there happening within a certain interval, but once we've highlighted 1, how long did it take for that 1 to happen? And when I say how long, I mean how long along the x-axis. What is the interval of x's? Like how long on that horizontal length did it take for that to happen? So for example, on the first one, we said 1 cycle was this guy right here, right? So if that starts at 0 on the x-axis and ends at 1, 2, 3 on the x-axis, then this period is 3 units, because it took 3 units along the x-axis. That's the horizontal length, how far on the x-axis it took for that 1 cycle to happen. Okay. Now here, just for some variety, let's say I wanted to start my cycle right here, okay, and then I go up to my maximum here, and then I'm going to come back down when I hit my minimum again. That's where I started. There's 1 complete cycle. And this one, let's say, starts at 2 on the x-axis, and I know I'm a little off there. Just pretend that's right about at 2. And then this one ends at 8. So if we're starting at 2 and we're ending at 8, we would say that that cycle took 6 units to complete. So we would say that the period for that 1 cycle is 6 units. And it doesn't matter where you start and stop. You should be able to count out how long it takes for one cycle to happen. So if I go back up to this picture, I started at 5 on this pink one here, and I ended at 11, and from 5 to 11 still shows me that 6 units. Okay, or I could go from -1 to +5 here, and I still get 6 units. So as long as you're correctly identifying one cycle, you should be able to count the horizontal length, or how long it takes for that cycle to happen, and we call that the period. And one more here. Okay, let's say we identify this one cycle of this periodic function. If we start at 0 and we end at 6, then we would say from 0 to 6 is again 6 units, so this period is 6 units. Okay, so we should be able to identify a cycle because that helps us figure out the period. That's how long it takes for one cycle to happen. And then we also need to be able to identify something we call amplitude, and this is going to be related to our midline. The amplitude, which we'll call A, just like period we called P, the amplitude of a periodic function is half of the height, and that's the total height. Half of the total height. So it's basically the distance above or below the midline. So how high above or below the midline does our graph go? So if we look on this first one, the maximum here is at 1, and the minimum, lowest value, is going to be at -1. That's a total height of 2. So if I was to draw my midline here, okay, my midline would go right along the x-axis there. We'd go 1 above that midline, 1 below. And so we would say the amplitude is 1. So we're going to say A is 1 unit. We are 1 unit above the midline, we are 1 unit below the midline, or if we take that total height of 2 units and divide it by 2, take half of it, we get 1 unit. Okay, now in the next one, we have a maximum at 0, and then a minimum happening at -2. And so the total height for this graph is also 2. And so we would put the midline at -1 here. So this would be our midline. Okay, we're 1 unit above that, we're 1 unit below that. So we would say that the amplitude for this graph, again, is 1 unit. Or again, you take that total height from 0 to -2. We say that total height is 2 units. And we divide it in half to get 1. Now I know we're going from 0 to -2, but if I'm measuring a height, a height's not going to be negative, so you don't really want to factor in the negative there. You just want to count the number of units we're looking at for height. Okay, I got one more. Let's see, this one. We have a maximum at 3, and we have a minimum low point at 0. So from 0 to 3 means the middle is going to be at 1.5. At 1.5 is going to be our midline. If I go 1.5 units up and 1.5 units down, I will get to 3 and to 0. And so our amplitude is going to be 1.5. So we could say 1.5 units. We could also say 3 halves. If we like fractions better, that's probably a little more appropriate at this level. But there it is, right? Or we take that total height of 3 and divide it by 2. So amplitude, period, cycles, identifying periodic functions, just some vocab to get us warmed up to some of the ideas we're going to see when we graph trig functions in our next couple of topics. Okay, so that should be good for this particular lesson. But as always, if you need some extra help, then just reach out. Until next time, take care, guys.